Hello there, welcome to Ethio-Hahu tutorial. Today we are going to see about solving quadratic equation using general quadratic formula. That is the second part of solving quadratic equation. In the previous video, we have seen about solving quadratic equation using factorization method. And today we are going to see general quadratic formula to solve the quadratic equation. The roots of quadratic equation. A quadratic equation is written in the form of ax squared plus bx plus c is equal to 0. Quadratic equation is second degree polynomial given by ax squared plus bx plus c is equal to 0. The roots of a quadratic equation is given by r1, r2 is equal to minus b plus or minus the square root of b squared minus 4ac divided by 2a, where the value under a square root is discriminant of the equation. The discriminant d is equal to b squared minus 4ac determines the nature of the solution. The first one, if d is less than 0, which implies b squared minus 4ac is less than 0, the quadratic equation has no real root, because the square root of negative number cannot be real. Therefore, the quadratic equation has no real root. Second, if d is equal to 0, implies b squared minus 4ac is equal to 0, the quadratic equation has one real root. That is, r1 is equal to r2 is equal to minus b over 2a, because if b squared minus 4ac is 0, the square root of 0 is 0. Therefore, minus b plus or minus 0 means minus b divided by 2a. And the quadratic equation has only one real root. Roman number 3, if d is greater than 0, that means b squared minus 4ac greater than 0, the quadratic equation has two distinct real roots. r1 is equal to minus b plus the square root of b squared minus 4ac over 2a, and r2 is equal to minus b minus the square root of b squared minus 4ac over 2a. These are the roots of a quadratic equation with discriminant greater than 0. If the discriminant is 0, then the equation has only one root, and it is known as perfect square. If d is less than 0, the quadratic equation has no real root. Having seen this, let's see the sum of the roots. Since r1, r2 is equal to minus b plus or minus the square root of b squared minus 4ac over 2a, this means r1 is equal to minus b plus the square root of b squared minus 4ac over 2a, and r2 is equal to minus b minus the square root of b squared minus 4ac over 2a. r1 plus r2 is equal to simply the sum of these two roots, minus b plus the square root of b squared minus 4ac over 2a, plus r2 is minus b minus the square root of b squared minus 4ac over 2a. This is equal to, since the denominator is the same, minus b plus the square root of b squared minus 4ac plus minus b minus the square root of b squared minus 4ac over 2a. This plus the square root of b squared minus 4ac by the square root of b squared minus 4ac goes minus b is equal to minus 2b divided by 2a. 2 goes with 2. Therefore, r1 plus r2 is equal to simply minus b over a, where a is the coefficient of the leading degree. Ax squared plus bx plus c is equal to 0, and a is the coefficient of x squared, b is the coefficient of x, and c is the constant. B, the product of the roots r1 and r2. Since r1 is equal to minus b plus the square root of b squared minus 4ac over 2a, and r2 is equal to minus b minus the square root of b squared minus 4ac over 2a. What is r1 times r2? r1 is minus b plus the square root of b squared minus 4ac over 2a times r2 is minus b minus the square root of b squared minus 4ac over 2a. We know a squared minus b squared is equal to a plus b into a minus b. Therefore, if we consider this a as a and this is as b, a plus b into a minus b, and that is known as difference of two squares. With that, minus b the whole square minus the square root of b squared minus 4ac square divided by 2a times 2a, 4a square, and this is equal to minus b square is b square minus b square minus 4ac divided by 4a square, b square minus b square minus minus plus 4ac divided by 4a square. B square goes with b square, 1a goes with 1a, 4 goes with 4, is equal to c over a. Therefore, r1 times r2 is equal to simply c over a. In general, r1 plus r2 is equal to minus b over 2a, whereas r1 times r2 is equal to c over a, where a, b, and c are constants. Having seen this, let's do example 1. Find the true set of the quadratic equation 2x squared minus 3x plus 7 is equal to 0. Solution. In this case, a is equal to 2, b is equal to minus 3, and c is equal to 7. First, we need to see the discriminant. Discriminant d is equal to b squared minus 4ac. This is equal to b is minus 3 square minus 4 times a is 2, c is 7. This is equal to minus 3 square 9 minus 4 times 2 8, 8 times 7 56, 9 minus 56 minus 47 d. Since d is less than 0, the quadratic equation has no solution. Since d is equal to b squared minus 4ac is less than 0, the quadratic equation has no real root. That is, true set is equal to simply empty set. Example 2. Find the roots of the quadratic equation x squared minus 2x plus 1 is equal to 0. Solution. A, in this case, equal to 1, the coefficient of the leading degree. B is equal to minus 2, and c is equal to 1. Therefore, the discriminant is equal to b square minus 4ac. b is minus 2 square minus 4 times a is 1, c is 1. Minus 2 square, 4 minus 4 times 1 times 1, 4, which is equal to 0. Since the discriminant d is 0, which is equal to b square minus 4ac, the quadratic equation has one real root, that is r1 is equal to r2. In this case, r1 is equal to r2. r1 is equal to r2 is equal to simply minus b over 2a, because minus b plus or minus the square root of b square minus 4ac divided by 2a. Since this is 0, r1 is equal to r2 is equal to minus b over 2a. Minus b is minus 2 divided by 2 times a is 1, minus plus 2 divided by 2 times 1, 2 goes with 2. Therefore, r1 is equal to r2 is equal to 1. Hence, the true set is the set containing 1 is the solution of this quadratic equation. The third example, find the roots of the quadratic equation 2x squared minus 8x plus 5 is equal to 0. Here a is equal to 2, b is equal to minus 8, and c is equal to 5. Discriminant is equal to b squared minus 4ac. b is minus 8 square minus 4 times a is 2, c is 5. Minus 8 square, 64. Minus 4 times 2, 8. 8 times 5, 40. This is equal to 64 minus 40, 24. d is 24, which is greater than 0. Hence, the quadratic equation has two real roots, r1 and r2. Therefore, r1, r2 is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. This is equal to minus b is minus 8 plus or minus the square root of b squared minus 4ac is 24 divided by 2 times a is 2. This is equal to minus plus 8 plus or minus the square root of 24 is 2 radical 6 divided by 2 times 2, 4. r1 is equal to 8 plus 2 radical 6 over 4, and r2 is equal to 8 minus 2 radical 6 over 4. This is equal to 8 by 4, 2, plus by 1 by 2, 2, radical 6 over 2, 1 over 2 radical 6, and r2 is equal to simply 2 minus 1 over 2 radical 6. Therefore, the true set is 2 plus 1 over 2 radical 6 and 2 minus 1 over 2 radical 6. These are the roots of the quadratic equation 2x squared minus 8x plus 5 is equal to 0. And this is all about solving quadratic equation using general quadratic formula. And next time we'll see another method of solving quadratic equation. Until then, have a nice time.